Alright, number 7 from the back of this sheet that I asked you to do for homework last night. So it says block B that's sitting on a table, it's 12 kilograms. A and C are hanging off either side, and it's asking you to find C. This will be FGC, this will be FGA. It tells us that the mass of C is moving to the mass of B is moving to the right, which means friction is going back this way on B. Okay, so if we were to draw it in a straight line, pulling this way will be FGC and it will be positive, and pulling backward will be FGA and FFR on B. Okay, so what is the mass? So we're going to do of C. So sum of the forces is equal to M total A. Oh, and it also tells us, I didn't write it down, acceleration is 2 meters per second squared. All right, so FGC minus FGA minus friction on B will equal MA plus MB plus MC times A. So MCG minus MAG minus mu Fn on B, but Fn on B should just be Fg. So this will be MBG. And then you have to multiply this out because you have an MC caught inside here. So MAA plus MBA plus MCA. And you're trying to solve for MC, so take the two terms with MC to the same side. So MCG minus MCA is equal to MAA plus MBA plus MAG plus mu MBG. Factor out your MC, G minus A, and then divide by it. So MC is going to equal MAA plus MBA plus MAG plus mu MBG, all divided by G minus A. So now fill in your numbers. A was 4 kilograms, MA that is, and the acceleration is 2 meters per second squared. B was 12 kilograms, 2 meters per second squared. 4 kilograms times 9.81 meters per second squared plus 0.25 times 12 times 9.81 meters per second squared. And on the bottom, 9.81 meters per second squared minus 2. So on the bottom, 7.81. On the top, 8, 24, 32, 71 point something, and another quarter of that, 330. Divide out, and you should get, I'm totally cheating, 12.89 kilograms. Okay? Number 7. Now number 8 might look a little nasty, but it's really not that bad. Number 8 is really just 2 inclined planes that are back to back. Okay, so this one has an angle of 30 degrees, and this one has an angle of 53.13 degrees. This is block A, pulley block B. And it tells us MA is 100 kilograms and MB is 50 kilograms. And the first question is, which way is the system going to move? It's frictionless. So the only forces that are going to cause this system to move is MGAX and BX. So which way is it going to move? It's going to depend on which one's bigger, right? So pulling one way will be FGBX, and pulling the other way will be FGAX. And because there's no friction. So which way it moves depends on which one's bigger. So find FGAX. It's just the opposite side, so MAG sine theta. So 100 kilograms, 9.81 meters per second squared, sine of 30. So FGAX is going to equal 490.5 newtons. FGBX is MBG sine theta. So 50 kilograms, 9.81 meters per second squared, sine of 53.13. That's 0.8, and that's 490.5. So 392, assuming I punched that in the calculator correctly, 392.4 newtons. So A wins. So it's going to move, this way is going to be positive. So that's part A. Part B is what will the acceleration be? So now do sum of the forces is equal to M total A. So it'll be FGAX minus FGBX is equal to M total A. So A will equal, well, we have these numbers, 490.5 newtons minus 392. I think it's a 9. Oh, it's a 4. Sorry, can't make up my own writing. Newtons, and then divided by M total, which is 100 kilograms plus 50 kilograms. Okay, so minus plus 490.5 divided by 150, and I should get 0.64, 0.6, I get 654 when I just typed it in, even though the sheet says 55. Could have screwed up somewhere. And then what is the tension of the cord? So it really doesn't matter which one you look at, but you have to look at one or the other. If we pick A, there'll be FT pulling this way, and FGAX pulling back, and you do sum of the forces is equal to MAA. So which way is positive? This way. So FGAX minus FT is equal to MAA. So take this over, bring this over. So FGAX minus MAA is equal to FT. Fill in your numbers. So 490.5 newtons minus 100 kilograms times 0.654 meters per second squared, and the tension, so times 100, so 65.4, and then take that away from 490.5, and you should get 425.1 newtons. Okay, and if you did it on the other one, you still should get the same thing. All right, so that's number 8. Number 9 is a little bit trickier, perhaps. So number 9 is an inclined plane with mass 1 and mass 2 hanging on it, sitting on it, and mass 3 hanging down. So M1, M2, M3, and I'm going to run out of time here. It says they're connected by a cord passing over a pulley at the top of the incline. The incline is 30 degrees. So this is 30 degrees. M1 is 20 kilograms, and mu1 is 0.3, friction between this block is 0.4, sorry. 0.4, and that's static, and mu kinetic is 0.3. M2 is 30 kilograms. Mu2 static is 0.3, and kinetic